So in the last section, section 4, we looked at creating ORC format tables by creating an external table and then creating an internal ORC format table on top of the external table. So basically what we're doing is, in this section here, we're going to create dynamic partitions. We're going to use the parks table that we used earlier, or the parks CSV file which we used earlier, and we're going to partition this particular table by state. So for each new state, it will create a new directory with all the records belonging to that state in that particular partition. So first thing we want to do is we want to create this table, state partition. And it's going to have all our fields as before. So park ID, which is a string, park name, which is a string, a park alias, which is a string, and park alias is a string, city is a string, and country is a string. Okay, now we don't specify the state field here, so we do park ID string, park name string, park alias strings, city is a string, country is a string, and we tell it that we want to partitioned by state, which is a string, and then we want to stored as ORC. Okay, so we've done that. So we want to create an intermediate table and load the data into the intermediate table, and we'll use the table parks previously created. So if we do describe parks, it's already there, and if we do a select asterisk from parks, it's already got the data there from the previous section. So in order to create dynamic partitioning, we set the hive.execute.dynamic property. So set hive.execDynamic.partition equals to true, and we set the hive.exec.dynamic.partition.mode equals to non-strict. And we need to run those before we actually create our dynamic partitioning table. So insert table data now into table, partition by state. Note the state must be the last column listed in the select statement. So let's go ahead and insert the data. So insert into table state partition, and partition is state, and then select park ID, park name, park alias, city, country, state from parks. So it sets up a MapReduce job to complete this task. So because we had parks, an internal table called parks already created, we are just using the data from that intermediate table to create a partition table, which will store all the data from this CSV file in partitions based on the state, which is all the different states of the US. And once that MapReduce job is completed, we can then go to HDFS and we can list all the directories created from that table, state partition, and will be able to see that it's under user Hive warehouse because it's an internal table. It creates a directory called state partitions, and then for each new state that it finds, it stores all the records grouped by that particular state. So it's like a group by clause, takes all the records and groups them by their state and stores them in a separate directory. Okay, so if we have a look at our HDFS and we have a look at the user Hive warehouse directory, you can see that there is an entry here. It's a directory and it's called state partition. So let's have a look at that. State underscore partition, which was the name of our table. And you can see that it has created an entry in here. So it's created a directory for each of the states that it finds. So let's go into one of them. State equals ON. And it has records in there belonging to that particular table, which is grouped by state ON. Okay, so that's it for that particular section. In the next section, what we want to do is create collection types. So collection types are available through Hive. So when you're creating tables, you basically tell it what type of collection type you're using, whether it's a struct, a map, or an array. So details regarding the struct are in angle brackets. So you create a struct which is similar to a record data structure. ID is of type int, name is of type string, manager is of type string. And then you have an office, which is an array of strings. And then you have budgets, which is a map of two integer values, so int and int. So maps are like lists of key value pairs. Each row is delimited by a comma, and the collection items are terminated by $signs, and the map keys are terminated by colons. Okay, so go ahead and create that table, and then we want to create a text file which represents this particular department's table. So create a text file, put it up onto HDFS, so you have things like 100, which is the ID, and then computing platform, and John Nash. So that would represent the struct, which is ID of int, name of string, and manager of string. So the name of this company is maybe computing platforms, the name of the manager is John Nash. And then we have offices, which is of an array of strings. So the offices that we have are London, New York, and Dublin. And then we have budgets that are available. So budgets are made up of a map, so two values, int and int. So for example, if you had a budget of 2011 was so much, in 2012 was so much, in 2013 is so much. So create the text file using this format, and then go ahead, put it up under user Hive, the departments text file, or maybe under user Hive /departments, and then attempt to load that data into the table departments, and then you should be able to select various fields from that departments table. So you can do select asterisks from departments, select offices from departments, and it'll give you the 3 offices, or select budgets from departments and it'll give you all the budgets from the map data that was inserted earlier. So once you have that done, then attempt to create a Hive table which includes buckets, and experiment with the bucket sizes. Okay, thank you.